everyone from around the world. My name is Musa Hamrauni. I'm trainer from Praba Engineering Service. In this session, I want to explain to you what is the subject training of Civil 3D from the start to the end. Praba Engineering Services is your home to upgrade skill in civil engineering software, such as drone, topographical instrument, software for modeling, and software for analysis. I will explain about the Civil 3D training. Civil 3D is infrastructure software to create modeling for road and master plan. First, I want to give you the introduction of the zone of UTM. Zone UTM is divided in a couple locations. Divided in some location, it is need to be delivery to you because before we get the very complex design, we need to know which is the precise of location. Working in infrastructure is different with the working with the building. When we work on the building, we just concentrate in one place, but in infrastructure, sometimes we need to move to the other location. The area is very wide. You can imagine for the design of rail, design of road, sometimes from the area A to area B is very long. So we need to know about the precision location by UTM. In the first subject, we want to explain to you how we can check the location by produce key ML and key MZ, and then we can share the key ML and key MZ to everybody in our office or to the client. You see, we have the sign in here. This is the draft of alignment. If the location is already precise, they will put on the Google Earth correctly. But when we have the setting UTM, it's not correct, they will be to another location. And this could be wrong. This is the correct location. I want to delete to check. And this is, I already make some modification, then I save, I export again to make sure this is the wrong location. This location is in here, but our marker is in here. Make sure the location is precision by setting in here. We need to adjust the datum, the location exactly in the top of the equator line or bottom of equator line. And then we need to know and make sure the drawing depends on the standard drawing you follow in feet or meters. Next, we go to the import point data surface. The point is from instrument survey, looks like total station or RTK, or from LiDAR, and then we create surface. I want to give you example. This one we have point from data topo. When I change the scale, the data point will be shown in here. This is from the total station instrument. We have a number of points, we have elevation, and we have a description also. The description is used to recognize one to another location, such as center line, ditch, and another specific location. After we have a point, we go to surface and then create surface. We create surface and we can modify by surface properties, and we can adjust the style of the surface like this. Also, we can change to contour mode. We can check the water drop, we can check the catchment area, and we can add the label in here from slope, like this one, or we can check by the contour label like this. It's so many label in here. I will delivering to you. Next, go to the horizontal alignment. Horizontal alignment is a simple line when we want to design from the A location to the B location. We have many options. The first option is the simple one, from the point A to point B. Then we consider of the obstacle in here. Sometimes we have swampy area, or we have the hill that if we will construct that location, it will be take the price so high. This is option B. Another option is the option C. The option is depending on your design. You will be designed for toll road, for urban road, for rail, for irrigation or canal. It's very depend on the situation and location. The horizontal alignment, it consists of tangent, radius, and spiral. We have in the middle, which is the radius and spiral is depend on the criteria design you want to use. Then this is a final decision. This is the alignment. This is the alignment or trace we can use for the canal, for the road, or the rail. It's not so many different. We can start by alignment, but we can start by create alignment by layout. We need to adjust the name, change the name. This one, this is the starting station by default, 0 + 0 0, but you can modify if you work in the middle or anything you want. You can type, and you can just start from here, tangent with curve like this if you want to design. The radius is depend on the criteria design. This is the station level. By default, the sign speed is 100 km/h, but we can delete first. And then this is the beginning of project. Start in 100. So every 20 meter, they will mention the station level. But you can modify in here. If you want to every 50 and this every 25, you can adjust the model. And then you can import the label. We have so many label in here. If you want to make a cross line like this, different client is different style, right? It's no problem. We already have the route, and then after we have alignment, we go to longitudinal alignment. Before is the horizontal alignment to design left and side turn, and this is the long alignment, or we can say profile. This is from original ground level. Original ground level option A. This is the original ground level option A, B, and C. After we decide which is the best location. Okay, you have longitudinal alignment. We have automatically created by surface existing ground option A, B, and C. Then after you have the last decision, we can create the profile for the design. This is the final elevation. We go here. We create this one first by check the profile, create by surface, then alignment. We need to connection from the alignment and the surface. Then we make merge in here, and don't click OK, but you need to click draw in profile view, because if you click OK, the database will be right on the computer, but there is no printout in here. So you need to check by draw in profile view, go to the next, or you can directly create profile view in here, and for the setting it will be do on the last session. Click in here. This is the existing ground level. This is we call long section. This is the profile band set. This one is for the longer one. This one is for the short one. Let's connect with this one. I want to move here. Okay. Existing original ground level. For example, I go in here. So the line of the existing ground level will be changed in here. Then we need to create profile by layout to design of a finishing level. Click in here. Then you need to name finish ground for Canada route. For the name of the route, and then okay, you can directly by draw tangent with curve in here. If you start from the top of the original ground level, it means it will be embankment in here. If you go to under of this line, the original, it means will become excavation in here. For the practice, it's okay. You can adjust by your own style. But in the reality, you cannot do like this. You need to follow the guidance from the work specification. This is the start of project, and this is the existing. We have a chainage in here. Start in station 100, and we have existing. This is connect to this one, and we have the project elevation. This need to connect this one, but for now, they still same, still not connected. So we need to change by right click in here, profile view properties, and adjust the bands. This is the project elevation. Go to the our new name. This is finish grade Canada route, and then another one too. We need to change, and then okay. Okay, make sure everything is follow the green by green and red by red. If you want to change the design, maybe you think this is too high for the embankment, you can go to the lower one. And actually the label is already changed in here. Like this one. Okay, you see? Okay. This is represent vertical alignment for here. For vertical alignment, horizontal alignment is represent in here. From here to here is 46. Then curve with radius 200 and other location. But for the super elevation, that is not mentioned until now because we will adjust on the end of the session after we create the cross section. Next subject is create assembly. For assembly, it's depend of the typical you have. You want to work for the rail, you want to work for the common route, or you work for the specific route, such as the hauling route or the access route. Then we go to here by create the corridor, create assembly, and then create assembly. Then by corridor and create assembly, then you put the name, type 2 for example, and then okay, choose in here. Make sure you have marking to make it not lost because the scale is 1 by 1. Go to the assembly tool palette, and we have so many options in here, from the basic, lane, solder, and then median, curve, daylight. The lane is for the pavement, the solder is for the left and side after pavement solder, and the median is usually middle. Curve is for the gutter or canteen. Daylight is usually for the slope. The slope for the cut or fill. We start from the simple one, lane super elevation AOR in here, then go to the solder. Solder extend all, we can adjust in here if you have a different pavement or in here for the same level of the top. Then we have to generic link to surface, click in here to make sure everything running well. We need to adjust one by one the pavement. We have this one. This is for the width of the pavement in one side. We can change if you want, or you can modify a wider. It depends on your design. This is pavement number 1, number 2, number 3. If you use the concrete 30 cm, you can adjust like this. If you use the flexible pavement from the asphalt, 5 cm, because this by meter, so if you want to use the 5 cm, you need to 0.05. For solder, it's same with the properties. You can change in here. For the side of this is the slope for the left and the right. Then for the next is same with the main road. Then go to the slope and we change this one. For the right side, we just simple using the mirror. Don't type M and I because this is not AutoCAD. This is the database, so you cannot use type like this. It's a different function. The corridor 3D model. Corridor 3D model, set target and set all frequencies. Okay, corridor 3D model is in here. Corridor, then create corridor. We need to create the name. Then we choose the alignment. We check the profile, which one. This is using the surface or using the finished grid. If you want to create design for the overlay, you can use the surface. But if you want to full design, you can to use the finished grid. Go to assembly, which typical you want to use. I have type number 2. Then go to target surface, which of the surface you want to target. So the surface is connect with the design. I want to choose this one and then OK. Then set of frequency. This is by default 25. You can modify if you want to make more dense. 5, 5, 5. It's okay. Okay, then set all frequency, set all target. It's already target to the original ground and okay, okay. This is that what we call corridor. Corridor is 3D model from assembly, connect with the alignment and connect with the profile. For draft, we can adjust and modify like this. The corridor will be followed, but for the already final, I think is you don't need to do like this because it's just manually trial and error. This is what we call corridor. Like this. On the left hand, we can see this is the cut location, excavation location. And on the right hand, this one is embankment area. You can see the drive to in here. Just choose Chrome, and you can see the drive. So this is the 3D model. We can imagine the actual location will be like this, or you can change the visual by more by realistic. So the visual of the picture is better. Click here, go to the drive, click on the crown again. Crown, it means the placement of the camera in the middle. Okay, you can see clearly this is the pavement on the middle and something or the grass on the left and the right side. Okay, then close. The next step is after we build 3D model, we create the detail of information. Corridor, go to the sample line. Sample line is the planning, which location we want to create the cross-section detail. Every 25 or every 50 is depend on you. And by access in here, create sample line, then enter. We choose the alignment we want to produce the sample line, and you need to type every how many meter you want to use sample line. Per 25, it means I want to create a sample line every 25 meters. This is the name of the surface, and this is the name of the corridor. Okay, then go to here by range of station. We have a start station and station. Then we have the left side and right side, which the width you can adjust. 15, it's okay. Or if you have a road so wide, you can modify. Or the latest you can modify too. After we already type in here, you can modify after sample line already done. No problem. This is the every 25 meter as we create in here. Or if you already type 50, you can modify by 50. Or you can adjust every 25 meter in tangent, and every 5 meter in spiral, and every 5 meter in curve. So many options. Then okay, and then okay. If you want to add more in the abutment 1, abutment 2, pipe culvert, for example, in here, just enter. It's already add one sample line. And for the next step, we go to the cross-section detail. For the cross-section detail, we can access from here. We have some options, section view for one, and create multiple section view for all cross-section. I want to choose the alignment in here, and this is every 25 already created by sample line, and then next. Then I want to choose draft for the first time, and I want to use the style plot all. Then next. For the band set, I am using the 0.5 bidding. Then create section, and here this one is cross section 325 meter. This is the corridor. This is the existing ground level. I want to change the scale by 100. Wait a moment. This is this what we call the cross section, and this what we call the cross section band set. I want to delete the level different and change it in here, because this is a double information from here and in here. I want to modify by click in one object and right click, section view group properties. Make sure you choose with the group, because if you only section properties, they will be changed for only one cross section. Change band set. I want to delete this one and delete the title. Okay, then okay. Then I want to change the style. This is very ugly when I plot on the paper, so I want to change the style. In here we have section. This is for the existing, and this one for the corridor. I want to change the style by label without hatching in here. Okay, you see this is the blank on the inside and already mentioned with a grid already mentioned in here. This proposed for the elevation for the top, existing is elevation for the existing, and offset is the distance from the middle to the left. This will be following the design. Next step is create surface design. We can create surface design by here, and then we can go to the surface. The creation of surface is same with the first time we create surface by point, but the difference is we just access from the corridor in here. We just name it by top, and then I want to use the code top, and then this one. The detail why I want to choose top, pave 1, surface, and base will be explained on the training session. This one is top link, and then boundary. We need to create extend boundary. For the style, I want to create by elevation bending, so the surface color is very beautiful. Now this is what we call the surface design. When I check by object viewer, kind of a blanket covering the corridor. This is the surface design. And then escape. From the corridor we need to add to the cross section. Just click one cross section and sample more source. We need to find which is the surface top in here. And the style I want to change by another style, and the color, line width, and etc. I already modified. Okay, the red line is the surface design covering the corridor. So from here, this is still wrong. The elevation still following the existing ground, and we want to change by this one, section view group properties. Go to the change band set, then go to here. We have surface 1 and surface 2. The surface 1 change to the top, and okay, let's see what's going on. This is correct or not. For this one, I want to make sure the design is under the existing ground level. The design is proposed 473 in here, and then the existing ground is 474 in here. It's already correct. Step is, after we create cross section, we create the quantity. The quantity we can get from the cross section by comparison of the existing ground and surface design. We already have the existing ground design too, but for the training I want to give you another surface in here, because the value of the pavement is different with the common embankment. So for short, I want to give you sample from here. Compute material, and then okay. Go to the finals. Go to the surface existing ground level, and go to the surface design, and okay. All of the excavation will be shown in red. and all of the embankment will be shown in green. Then we just calculate total volume and split in here. This is the volume of the cut and fill in this area from here to here. The design compared to the existing ground. Some location excavation, some location will be embankment. And this is the result. Every section already mentioned in here, and the total project you can see on the lowest one in here. Next case is quantity, then plan production. Plan production will be explained in the training. We need to prepare for the sheet in here. You can change by your logo of your company or by yourself. We can adjust the profile in here. Then CAD tool is a very powerful instrument for you. And then super elevation, we need to create the super elevation for the every cross section. Super elevation start with alignment. We need to adjust the typical in here. And then the result will be every turn in here. I want to send to back. Every turn in here, if the curve is turned to the right, so the left will be higher than the right. Location 175. This one will be like this. The pavement is not equal like this. Will be explained on the training. Next is a simple master plan. The simple master plan is to create cut or fill easily by raising or lowering the elevation in the design. Then for the grading, it's more complex. We have some 3 or 4 of the grading style: grade to surface, grade to elevation, grade to distance, and grade to multiple surface. We can get the material take off. We can get the cut and fill in here. Then now the subject is which case you want to request. We can discuss. Maybe you have some difficulty on your project. This is the explanation for our training. If you still curious for the detail, you can contact me by WhatsApp. So don't be hesitate to call us. Because we provide full service of training. See you. Bye bye. Bye bye.
Hundreds of people already joined us.
We are here for you and we are waiting for your questions.
Sampai beso mana ya.